So in this video, we will just introduce the concepts, right? And from the next video, we will dive deeper into the CO concepts, right? So let's get started. So the subject name is computer organization. So what is a computer? So the computer is a computational machine used to process the data under the control of a program. For example, we have this program, right, to add like two numbers. So the program is to add two numbers. The input data can be 2 3. So we want to add this 2 3 number using this add program. So the output will be 5. So what this computer does is it takes the input data, and under the control of this add program, it will give some output. So the computer system functionality is program execution. So computer is basically used for executing the program. So what then is a program? Program is a sequence of instructions along with the data. If we write any program in like any high level language, C, C++, Java, Python, or like any like other language, we will have some instructions, right? Like if, else, and while, for, and like all these things. And we have some data like variables, arrays, like set, dictionary, and everything. So the combination of data and instructions is the program. So then what is instruction then? So it is a binary code which is designed inside the processor to perform some tasks. So we have some binary code, and if we bind this binary code with operation, it will become instruction. Let's see the example here. Suppose we have this CPU which supports 8 operations. The operation could be like simple operations, such as add, multiply, division, subtract, and or not. Like only 8 operations. The modern CPU supports like hundreds and thousands of operations, but just for an example, we have this CPU with the 8 operations. Then the opcode will be 3 bits. So what is opcode? So opcode is the number of bits required to represent the operations. So if we have 8 operations, so the number of bits required will be 3 bits, right? Suppose we have this operation 0, 1, 2, 3, and 7. So to represent these numbers, we only need 3 bits, 0, 0, 0 to 1, 1, 1. So it will be log 8 base 2 bits. Just for an example, we have this binary code 0, 0, 0, that is bind with the plus or add operation. 0, 0, 1 is bind with this multiplication operation, and this 1, 1, 1 is bind with the AND operation. So if we bind some binary code with operation, it is called as instruction, and all these operations are designed by the designer, and it is stored in the ROM, right? So next we will see what is data. So data is a binary code which is associated with a value based on the data format. So what was the instruction? Instruction is a binary code bind with operation, but if we bind the binary code with the value, right, this will become the data, right? Suppose we have the 0, 0, 0. If we say this is 0, 0, 0, 1, if we say this is 1, that means we are binding this binary code with some values. So that is become the data. And suppose if we call this add, if we call this multiply, so we are binding this binary code with some operation. So then the same binary code will become the instruction. So this is what instruction and data is. But there is like one important thing in the data. So it is associated with the value, but it is based on the data format. So the value of this data can be different depending on the data format. So like we will study the data format in detail in the like upcoming videos, but here we will like touch this briefly. So for example, we have this binary code like 0 and 0. So the value of this binary code could be 5 or -1 or -2 or -3, or even can be fraction depending on the data format. So if we take data format as unsigned, the value of this code is 5. If we take it as signed, it will be -1. Similarly, for 1s and 2s complement, it will be -2 and -3. And if we take this as a floating point number, it could be a fraction as well. Let's see how this 5 came. So we know how to convert the binary to decimal, right? So suppose this number is 010, we have this 012, right? So to convert this to decimal, what we will do is we will take this number 1 into the base will always be 2 because this is binary number, and then to the power this number 2, right? Then plus, then this number 0 into base will always be 2 and the power will be this number plus this 1, base will always be 2 and then this number, so it will be 4, 0 into anything 0 plus 2 power 0 1 and 1 into 1 is 1, so this is 5. So this is unsigned. So the value of this binary code based on this unsigned data format is 5. Now let's talk about the signed. So if any number is start with like 0, this number is considered as positive. If a number start with 1 here, so this will be considered as negative number. So we have this 101 number. So this 1 is MSB, most significant bit, and this is LSB, least significant bit, and this MSB beside the sign. So here we have this 1, that means it is negative, and then we take the value of this. So 01 is 1. So the value of 0, this 101 is minus 1 in signed, right? If we take this number, so this 1 is for sign negative and this 001 is 1, so this will be also be minus 1. Now we will go to 1's complement. What we will do is we just invert the bits, so this 1 will become 0, this 0 is 1, 1 is 0, so and then what is this? This is 2 only, and actually due to the symmetry of binary numbers, if a number starts with 1, we consider them as negative, and if it is 0, it is positive. So the number starts with 1, so we have this negative sign. So in the 1's complement, the value will be minus 2. 2's complement is 1's complement plus 1. So number is 101. Its 1's complement will be the like inversion 0, 1 and the 0. We will just add 1 in the here. So it will become 1, 1 and 0. So this is 3, 0, 1, 1 is 3, and this number starts with 1, so we put the minus sign. So we just saw that we are getting this 5, minus 1, minus 2, minus 3, and we will see in the floating point numbers we can get the fractions as well. So depending on the data format, the value of binary code could vary, and if we are talking about the binary code bind with the value, this is called as the data. Next, we will see the user view and the designer view of the computer system, and and what all we're gonna study in the computer organization. So first, start with the user view. Suppose we have some pseudo code like user code of some program, then we write the program in some high level language, right, and then we compile this. It will convert the high level language to the assembly code, then it will be converted to the hexadecimal, then to the binary, and suppose we the output is 3-bit binary code, right? So here we will use the 3 into 8 decoder, right? The decoders have like an input and 2 to the power n output. So if we have 3-bit input, we will have 8-bit output here. So what does this mean is, suppose the 3-bit output code is 000, that means this value is 0, so this S0 will be 1 and everything will be 0. So suppose we write some like code here, it will get this converted, and finally we get the 000 as the number here. So it will get into the decoder, and what it will do is, it will the S0 pin will be 1 and everything else will be 0, and based on these signals, base hardware will perform the computation. Similarly, if the 3-bit code is 001, the value of this is 1, so S1 will be like 1 and everything will be 0, and depending on this, these base hardware will perform the action. So this is the broader picture of how computers work. And in the computer organization, we study from assembly code to the base hardware. We study this compiler in the compiler design course, and these things in the programming DS and algorithm courses. So this is the user view, and the reverse of this is the designer's view actually. So this ECE people design the base hardware and like signals and how many operations this base hardware supports. Right? Suppose ECE people design this with the 8 operations. So we will have this encoder. In the decoder, we have L into 2 to the power n. That means L3 is the input, 8 will be the output. The reverse of this is encoder, in where if we have 8 as input, the output will be 3 here. So for example, suppose we have the input as this is the 8-bit 3662, and so here S1 is 1 and everything else is 0. So the output will be this 001, right? Because the value of this is 1 and here S1 is like true or 1. So this will become 001 will become the encoded binary code. Then similarly in the reverse manner, it will get converted to hexadecimal, then assembly, compiler, and then high level language and user code. So this is how designers like see this system, computer system. But as a user, we see this computer system like this, because we first write the code and it will get like compile assembly code and hexadecimal and things like that. So like this is the broader picture of how computers works, and what like all the components falls in the computer like organization. So this is just the basic concepts of CO, and from the next like video we will go deeper into like all the concepts.